Hello Year 10 and welcome to the first lesson in a new topic on sequences. And we're going to start by finding the nth term of an arithmetic sequence. Now this you will have seen before, but we're going to tidy your knowledge up a bit by using the proper mathematical terms and just making sure that we can apply what you already know to heart. So the majority of this is going to be revision. So what we've got here is a sequence. This is the one going along underneath. So 4, 7, 10, 13, 16, 19 are the terms in my sequence, and that would carry on. I've just chosen to stop here. And along the top is the term number, and I've got an N in brackets here, and we'll talk about that more shortly. So the first term in the sequence is 4. The fifth term in the sequence is 16. So that's what the term number is. It's telling you the position within the sequence that the term has. Now, an arithmetic sequence, you might not have heard it referred to as that before. That's a sequence where we are adding on a consistent amount each time to get to the next term. So 4 add 3 is 7. That gets me the second term. Add 3 again to get 10. And add 3 again, etc. So it's always add 3. Now, it's really important when you are looking at sequences and trying to decide what's going on that you don't just look at the difference between the first two terms. You should do a few just to make sure that you are dealing with an arithmetic sequence, because there are going to be other types that we look at. So you should be in the habit of finding the differences, but doing that for more than just the first term. So this add 3 is called the term-to-term rule. That's how I get from one term to the next term. And that will apply to all sorts of sequences. We'll refer to the term-to-term rule. But in the case of an arithmetic sequence, we're always going to be adding or possibly subtracting. And that is called the common difference. So the common difference for this sequence is add 3. Okay, so here's another example. What I'd like you to do is pause the video and copy down the term numbers and the terms underneath. Find the term-to-term rule by drawing arrows underneath, just like we saw in the last example, and then also find the next 3 terms by filling in the blanks here. So pause the video and give that a go. Okay, so you hopefully found that the term-to-term rule was add 5. So the common difference for this sequence is add 5. And then I can add 5 to get the 4th term, add 5 to get the 5th term, and then add 5 to get the 6th term. Okay, so here's another example for you to do the same with, and you're going to need to pause the video. Just take note though, the terms are getting smaller, so this is a decreasing sequence. So pause the video, copy this out, see if you can find the term-to-term rule and mark it on using arrows underneath, and then find the next 3 terms. Okay, so you should have found that we're subtracting 4 every time here. So the term-to-term rule is subtract 4, the common difference is negative 4, and I can keep subtracting 4 to get me the next 3 terms. So that should be the answer that you found. Okay, so if we look at this sequence here, this should look pretty familiar to you. 3, 6, 9, 12, 15, 18. This is the 3 times table. And of course, the 3 times table has a common difference of 3. We're adding on 3 every time to get to the next term. But hopefully, because you know your 3 times table, you also know that the first term in the 3 times table is 1 lot of 3. And the second one is 2 lots of 3, which gives us 6. The third term is 3 lots of 3. Then we're going to have 4 lots of 3, 5 lots of 3, and then 6 lots of 3. So you can see 3 times 2 is giving me 6, 3 times 3 is giving me 9, 3 times 4 is giving me 12, and so on. So now we're going to talk a bit more about this n here, which is referring to the term number. So this is algebra, and if we want to generalize what's going on here at this sequence, we want to say, what do we do to the term number to get the term? And hopefully you can see that what we're doing is we're multiplying the term number by 3. So we want to communicate that in a more general way. If we say the term number is n, what are we doing to n to get the term? We're multiplying it by 3, so 3 lots of n. And so our term number is always going to be 3n. And that's really powerful because now if I want to know the 100th term in this sequence, I don't need to keep adding 3 until I get to the 100th term. I can now say, well, the 100th term will be 3 multiplied by 100. It will be 300. So that's the nth term, or the term number to term rule. It's the rule that takes us from the term number to the term. Now, actually, this is linked to the work that we've done really recently on straight line graphs, because essentially it's exactly the same thing. If I change my term number to be x and my term to be y, this is like the tables that we drew out to find the y coordinates to plot if we know that the graph we want to plot is y is equal to 3x. So we're taking each of our x values and we're multiplying by 3. So you should know that this number, this coefficient of x, is the gradient of the graph we would plot. And we know that that gradient is, for everyone along the x-axis, I go up 3 on the y-axis. And that's exactly what's happening with this term-to-term rule. Every time I go along 1 in my sequence, I'm adding 3. And so this is just a different spin on exactly the same knowledge. Okay, so another example, I'd like you to pause the video. First of all, find the term-to-term rule. So that's the one underneath with the arrow. So you're looking at how you get from one term to the next term. Then you're going to find the next 3 terms. And then you're going to have a look at this sequence, see if you recognise it, and see if you can think about what the nth term might be, the term number to term rule. So pause the video and see if you can answer those questions. Okay, so you should have spotted that the term-to-term rule is add 10. The common difference here is positive 10. And so to get the 4th term, I'm going to add 10 to 30. That gives me 40. The 5th one is 50. And the 6th one is 60. So hopefully you recognised this as being the 10 times table. And what do we do to the term number to get each term in the 10 times table? Well, we multiply it by 10. So I am multiplying the term number by 10 to get the term. And so my nth term is 10n. If I want to find the 1000th term in this sequence, I'm going to do 10 times 1000, and the term will be 10,000. Okay, so this, if we look at the sequence here, doesn't look like an obvious times table. So if I want to find the nth term for this, I'm going to start by finding the term-to-term rule, the common difference. So hopefully you can see here that the common difference is positive 4. I'm adding 4 each time. And I know another sequence where I add 4 each time, and that's the 4 times table. Now this isn't the 4 times table, but I'm going to write the 4 times table across the top. And I know that if I needed a rule for the 4 times table, I would be multiplying my term number by 4. And so my rule for the 4 times table would be 4n. Now that's not the sequence I've actually got, but if I carefully compare my 4 times table to my sequence, I can see that every time I'm adding 2. And so I also need to add 2 to 4n. And my nth term is 4n add 2. So just to recap, I look for the common difference, and that tells me what times table to write across the top to compare it to, and also helps me with this part of the nth term. And then I look for what I'm either adding, or it could also be subtracting, and I adjust my nth term. So what I'd like you to do with this question is pause the video and give this a go. Find the common difference, write the appropriate times table across the top, and use that to help you find the nth term. So pause the video and see if you can answer the question. Okay, so hopefully you notice that we are adding 7 every time. And that tells me that I want to compare to the 7 times table, because I know that that goes up in sevens as well. So across the top, I'm writing the 7 times table. And I know that to get from the term number to the 7 times table, I multiply by 7, which gives me 7n. And then when I compare the 7 times table to my sequence, every time I need to subtract 3. And so that means that my nth term is 7n subtract 3. Okay, so just looking at a slightly trickier one, these are decimals, but you're going to do the same thing. You're going to look at the common differences, and that will tell you about the times table that you need to write across the top. So let's say you needed the 0.3 times table. That would be 0.3, 0.6, 0.9, etc. So I'm adding 0.3 every time. Now that's not what you need here, but you're going to find the common difference. You're going to write the times table across the top and use that to help you find the nth term. So pause the video and give that a go. Okay, so you should have found that we were adding 0.5 every time, so the common difference is positive 0.5. And I'm going to write my 0.5 times table across the top. And my nth term for the 0.5 times table is that I'm multiplying the term number by 0.5 every time. So my nth term for that would be 0.5n. And then when I compare, I can see that I'm adding 0.1 every time to get my sequence. So my nth term will be 0.5n add 0.1. Okay, so here's your task for today. You're going to need to pause the video so that you can answer these questions. So in your books, I'm expecting you to write out the sequence. I haven't written the term numbers across the top here, so you can do that if you wish. You're going to need to find the common difference. Let that tell you what times table you need to compare to, and from that work out your nth term. So the ones in the amber box here should be relatively straightforward, and then these ones over here are slightly trickier. This one only because we start with negative, so you have to be fluent with your negative numbers to be able to do this. And here we've got some decimals and then some fractions, but still you've just got to work out what you're adding on every time, and that tells you the times table you want to compare to. So pause the video and remember to upload a photo of your work onto Teams when you're done.